Hi, my name is Bill Kinney. I'm a math professor at Bethel University in St. Paul, Minnesota. This is part 2 of a series of math videos that I'm making on how to do basic calculations with normal curves. Here was the problem we were looking at in the first video. Suppose we happen to know the resting heart rates of all adult males, maybe even pretend it's in the entire world, and we know it's normally distributed with a certain mean and a certain standard deviation. That part right there assumes that if we make a histogram of all the data for all the men, the resting heart rates, plotted along the horizontal axis with the relative frequency on the vertical axis, we're going to get a shape that's like a bell shape, and in fact follows a particular kind of bell shape called a normal distribution, also sometimes called a Gaussian distribution. You might also hear that phrase for the name of this distribution. And we want to answer two questions. First question is what we're focusing on here. What percentage of all men have a resting heart rate between 60 and 84 beats per minute? And the key takeaway from the first video at the very end was that the answer to that question is found by calculating the area shaded in blue here under the curve to the right of 60 and to the left of 84, between 60 and 84, because that's the numbers that we have up here, 60 and 84. I estimated approximately where they were on the curve by knowing the mean and standard deviation. I'm pretending I know the mean resting heart rate for all men to be 68 beats per minute. That's going to be where the middle of the curve is, the peak, and the curve is going to be symmetric about that vertical line there, because that makes sense that it should be. It should seem reasonable. And the standard deviation, sigma, is 8. That represents the horizontal distance between the vertical line and either inflection point, the inflection points being where the curve changes from concave down to concave up, to looking like a frown, to looking like a smile or part of a smile. I'll give you some more detail here then. Based on what I said before, 60 really is the mean minus the standard deviation. This is really mu minus sigma. What's mu plus sigma? That would be this number right there. It would be 68 plus 8, which would be 76. 76, that's mu plus sigma. To have a resting heart rate between 60 and 76 beats per minute means you are within a distance of 1 standard deviation from the mean. Again, in this case, the standard deviation is 8. You are within 8 of the mean. You are within 1 standard deviation of the mean. By the way, I think I mentioned this before. I don't know that these numbers are right. I just made them up. So we're pretending they're right. Turns out, this is something that's worth remembering, whether it's in a math class or even after the math class is over for your life. Turns out about 68% of the data that this distribution is modeling is within 1 standard deviation of the mean. The mean happens to be 68 here as well, but that's not the reason the percentage is 68. 68% of the data happens to be within 1 standard deviation of the mean. That's reflected in the fact that the area that I'm shading here without actually drawing it, under the curve between 60 and 76, within 1 standard deviation of the mean, that area is 0.68. Turns out the area under the entire normal curve is 1. This area is 0.68, or if you prefer 68%. 68% of the data are within 1 standard deviation of the mean because the area under the curve between 60 and 76 is 0.68. 68% of 1. 84, think about it, is mu plus 2 sigma. That's 2 standard deviations above the mean. There'd be a corresponding number over here at 52, which would be mu minus 2 sigma. 2 times sigma is 16. 2 times 8, 68 plus 2 times 8 is 68 plus 16 is 84. This is 68 minus 2 times 8. 68 minus 16 is 52. To have a resting heart rate between 52 beats per minute and 84 beats per minute means your resting heart rate is within 2 standard deviations of the mean. And it turns out that with these normal curves, 95% of the area, 0.95 approximately, a little bit more, is within 2 standard deviations of the mean. The area under this curve between 52 and 84, which I'm pretending to shade there, between 52 and 84, but that area is about 0.95, about 95% of the total area of 1, and that means that about 95% of the data are within 1 standard deviation of the mean. About 95% of all adult males, if my numbers are right, the 68 and the 8, are between 52 beats per minute and 84 beats per minute for their resting heart rate. But we're after the blue shaded area. Can we figure that out? Yes. Think about this here. Circle this in green. This area, this region that I'm circling, has an area, I said, of approximately, not exact here, approximately 0.68. I said that already, because that's within 1 standard deviation of the mean, between 60 and 76. The other part to the blue shaded area right there, we can figure out the approximate area of that as well, though it's a little trickier. Now I said the area here is 68%, 0.68, within 1 standard deviation of the mean, and the area within 2 standard deviations of the mean, between 52 and 84, under this curve, is about 0.95. Maybe pause the video, see if you can use that information to figure out what this area is right here. Okay, are you back? If you haven't paused it, do so. I really think you should try to figure it out on your own. Now we'll figure it out together. If this area is 0.68, listen carefully, think, and the area under the curve between 52 and 84 is 0.95, that means the area for these two pieces put together, think, has got to be 0.95 minus 0.68. Does that make sense? 0.95 minus 0.6 has got to be the area of these two regions, the circled region over here and the region uncircled between 52 and 60 over here. 0.95 minus 0.68 approximately. What is that? That's about 0.27. In other words, the area over here is about half of that. Half of 0.27 is 0.135. Now this is not a perfect approximation. I think the area is actually going to be a little bit bigger than that, but ballpark, okay? So now, this helps us answer the question. For the blue shaded area, now just add these two areas. The total area of the blue shaded region is approximately 0.68 plus 0.135, approximately 0.815. In other words, the answer to the question about what percentage of all men have a resting heart rate between 60 and 84 beats per minute, assuming this normal curve model is accurate, is going to be about 81.5%. We could be off a little bit. It might be closer to 81% or closer to 82%. I think it's probably going to be a little closer to 82%, but I'm not sure. let's say as a first estimate about 81.5% for this video, and in the next video we'll get a better estimate.